Bismillahirrahmanirrahim. Today's session is about the bar bending schedule, and I would like to clear those queries like how bar bending schedule is prepared and what is the reason of making a bar bending schedule in civil engineering for different projects, and why there is a need of making this bar bending schedule. So normally when we talk about the construction and we have different elements like beam, which is a line element, column which is a vertical cylinder element, and then we have slabs. And when we talk about steel, we have to use different configurations of steel in each element. So we have to calculate the correct amount of steel which we will utilize in our structure, so that we can get an idea of what will be the total amount of steel that we will be utilizing in our structure. सो बार बेंडिंग स्केड्यूल हमें बेसिकली एक आइडिया दे देता है कि हमारे पास कितना स्टील है, और हमने जो अपनी लेबर से आगे मटेरियल जो मंगवाना है उसकी जो आगे से हमने प्रोक्योरमेंट करनी है मटेरियल की, उस वो किस तरह हम कर सकें। और इसके अंदर ऐसा है कि एक चार्ट बन जाता है। वी बेसिकली मेक अ चार्ट। here you can see I will go into detail, but I will explain what is a bar bending schedule. So in this schedule, as I have mentioned earlier, we basically calculate the amount of steel for every individual element. If we make a separate bar bending schedule for beams, we make a separate bar bending schedule for columns, and for separate bar bending schedule for footing. So we basically calculate the amount of steel in every single element individually, and then we can, if there are some symmetrical elements, then we can just multiply our calculations. So when we come towards this chart which we make for bar bending schedule, here you can see here is the serial number and here is the bar designation. Bar designation is basically a bar number, like whether it is number 3 bar, number 4 bar, and number 5 bar. So this bar number we basically mention here inside this bar designation, and here we basically mention the number of bars that we have calculated, and here we mention length of bar, and then we mention die of bar, and here is the weight of bar. So what is the logic of this weight? Normally when we talk about the bar bending schedule, we know the weight per unit length for different bar. For example, if I talk about number 8 bar, let's suppose I have an arbitrary value x. I say that x is its weight of per kg. X is a number, let's suppose it is a 50. So 50 kg per unit length, for, let's suppose I talk about a meter. So I will be having this value with me, 50 kg per meter. So when I have calculated the total length of bar, I can just multiply that length by this number which we already know, which is basically the universal law for us. Then we can just multiply our length by this number and we can get the weight of our bars. So here is the shape of bar. So bars can be of different shape, like here I will give you an example of the bar bending schedule of a beam. When we talk about beam, so a beam is made up of longitudinal bars. It is made up of vertical stirrups, and if you further visualize, we basically have bent this longitudinal bar here in the upward direction and here as well. So we have to basically calculate separately for the steel for each and every element. Like if I talk about the stirrups, here we basically provide this bend in stirrup at angle of 135 degree for the purpose of anchorage, so that stirrup is able to hold the longitudinal bars, and it is able to prevent these bars from slippage, and it can prevent the longitudinal bars from the seismic actions, which is the earthquake loading. So I was discussing about the bar bending schedule. So if We know that this is the stirrup. We know that it is made of number 3 bar. And if we want to calculate the number of stirrup, we know that the length of it is, let's suppose, 4000 millimeter. Here it is mentioned. Then we can just divide this length by the spacing of stirrup plus 1. So this one is basically done to cater the first stirrup which is not encountered in a length divided by spacing formula. So length divided by spacing plus 1, when we do this, we are able to calculate the number of stirrups, and then we know the length we can calculate by adding it, and then we know the dia of bar will be, if it is number 3, then 3 by 8 of inch is its diameter. So we are able to basically calculate its dia, and then we can calculate weight of this bar. We basically know that weight fundamental law. We can also calculate weight by formula. This is basically an empirical formula which is had been calculated by utilizing different criteria. D square divided by 162, so it will give us the weight in kg per meter, but we have to put the diameter in millimeter. So if the bar is of 8 millimeter, let's suppose, then we would put 8 here, and it will give us the weight of that bar in kg per meter. So this is the basic formula for calculating, and we can convert the units, and it is also available in fit, in pound per feet, and just the denominator will change in that case. And we can just multiply the length by this weight per unit length, and we will be able to calculate the weight of our steel. So this was related to the stirrups. And when we talk further about the longitudinal bars, we can calculate the longitudinal bars. If we will look at the cross section of this beam, we will be having such dots, and we can calculate, count these number of bars, and then we know the length, and we will be able to calculate the longitudinal bars as well. In the same way, we will be able to fill this line. If we talk about these development lengths, when we provide, when there is a contact between steel and concrete in beams, we basically bend our bar by 12 die of bar. So we will be able to calculate it as well. And when we talk about this 180-degree hook, that is bent hook, we can also calculate its length by utilizing the formula which is basically given here at 20 into 10 power. So this is the basic. It will be like this in both sides, 180-degree bent. So it is also provided to make a good anchorage with concrete to prevent slipping of steel from the concrete, and to provide additional bone strength and protect against seismic loadings. So and crank, and there is also another thing in the bar bending schedule of beam. We basically provide crank length. Crank length is basically provided where there is a negative movement, so it is mostly 0.42 d, 0.42 d die of bar, this length. And another thing that we will find in the bar bending schedule of beam is the lap length. Lap length is basically provided because we know that steel comes in the length of 12 meter. We cannot load steel on a truck if its length is greater than 12 meter. So we basically provide this lap, and it has also formula in the terms of die of bar. Here will be a number which I am skipping in my mind right now. So we will be able to calculate it as well. So in this way we will be able to make a chart for our beam, and in the same way for every other individual we calculate the steel. So that was all related to the beam. I will upload about other elements of construction in another video. Thank you very much for paying your attention.